Okay, in this lecture, we'll learn about a few more important topics regarding Keras Sequential API. Well, if we want, then we can name the model like we can name a layer. So let's name the model. And now let's name the layers. And after compiling the model, before training the model, if we need, then we can check the summary. We can check the summary of the model. So compile it first. Okay, my bad. It will be output layer. And execute it again. And then if we want, we can check the summary of the model. And we can see the summary. The model name is NeuralFook and the input layer with 20 param, first hidden layer with 5050 param, second hidden layer with 1275 param, and output layer with 26 param. And the layer type is dense. The dense layer is a fully connected layer in a neural network, in an artificial neural network. Now let's go back at the app, and here we have divided data into two groups for training and test. We can use this test data while training a model here, and we can pass as named argument like we did for epochs. The named argument is validation data. Validation underscore data equal to the dataset. The dataset for testing. And we have to pass as a tuple. Here X test and Y test. One more thing. The X train is also called the train data or feature, and Y train is also called label data or label. Same goes for X test and Y test. The X test is also called feature test or test data, and Y test is also called label test or test labels. And the rule of data for training and testing is 80% data should be allocated for training and 20% data should be allocated for testing. And if we don't pass any name for sequential model or for any model actually, and then compile it, and then if we check the summary, then we will see the model name is automatically taken because it has been built for 4 times, so it's named sequential underscore 4. That's why it's better we name our model. Now let's compile it again, check the summary again, and we can also check the model training history. So let's train the model, and we're getting an error. The reason is we have named our model in the wrong way. Let's add underscore, okay, not underscore and no space. Reload it, check this summary, and train it. And we can see it's training. And if we want, then we can stop showing this training. Okay, so if we want, then we can stop showing it by simply saying verbose equal to 0 and train it again. And now we can see the training. And after the training is done, we can check the training history. For that, we have to assign it in some variable. I'm naming the variable history and training it again. Now let's add a new code cell, and here simply check it. Okay, we have to call its property, and the property is also named history. So dot history. And we can see it's a dictionary which is holding a list, and the first key is named loss. So if we want, then we can check the loss. Okay, check it again. And there is one more key which is named accuracy. And if we want, then we can also check the accuracy. Okay, I misspelled it. It will be ACURACY. Okay, so it's better we check the keys first, and we can do that using dot keys method. And we can see our dictionary keys are loss, MAE, value loss, and value MAE. So if we want, then we can check the loss and MAE. And also, if we want, then we can see the model training history in graph using matplotlib. So let's delete all this first and make the verbose 1 so that we can see the training. And now let's add a new code cell, import matplotlib, and show the graph of loss using the plot method. So plt.plot and then history and the loss. And if we execute it, then we will be able to see the training history, the loss history of the training. Now let's go back, go at the app, reinitialize the model and recompile it, and then training it again. And then show the plot of the loss again. And now we can get a great visibility. First, the loss was more than 250, and then it was near about 0. And we can see it here. At the end, it was near about 0, 2 point something, but at the beginning, it was 278, more than 250. In the same way, we can also see the plot graph for our MAE, mean absolute error. So we can say plt.plot and history and MAE. And it also goes in the same way. Now if we want, then we can also check the plot of the model. Let's add a new code cell, and here let's call the plot model method, which is under keras.utils namespace. So tf.keras.utils.plotmodel. And here we can pass our model. Our model name is LRMLD, and then we can say show shapes true, and then execute it. Awesome. We can see our plot model, and if we want, then we can save our model for future use. Simply, we can call the save method using the model name. So for our case, lrmld.save. And there are two popular ways of saving a model. First, we can name it saved model, saved_model, and actually it will create one directory by this name, and after that we can name our model. I'm keeping it simple and execute it. And now let's check it if it's saved or not. And we can see it has saved under saved model directory. And this one is our model. And if we want, then we can also save it as H5 format, which is popular as HDF5 format. Simply, we can call the save method, and here name our model anything we want. I'm keeping the name same, and at the end we will add .h5 and execute it. Now let's reload it, and we can see our model is saved as .h5 format. And now if we want, then we can use this saved model in future, and for that we can save it in a secure place. So I'm just saving it in my local computer, and it's saved in my local computer. So now let's add a new notebook, upload our saved model here, import the TensorFlow, and then let's load our model. Let's get the file path, pass the file path here, assign it in a variable, execute it, and before we predict, let's check the summary. And we can see it's same to same. The model name is NeuralFoc, input layer with 200 param, first hidden layer with 5050 param, second hidden layer with 1275 param, and the output layer with 260 param. Now let's predict. And here let's pass one data as vector. I'm passing 25. And we can see our prediction is very good. That's all for now. In our next lecture, we'll learn something more interesting.